So, good afternoon. Last time we looked at the Rees representation theorem in the context of finite dimensional vector spaces. We confine ourselves to the finite dimensional inner product spaces. That means which is a Hilbert space, as we shall see, that the terminology is used, and you know that the inner product spaces, the finite dimensional inner product spaces are all complete, and therefore they are Hilbert spaces. That we know. So, but we shall confine ourselves to the finite dimensional inner product spaces. So what we have seen is the following. You have the so-called Rees representation theorem. It says if f is a linear function, I think I was using this notation, y prime on a finite dimensional inner product space, we shall take dimension of x to be equal to n for the discussion over then there exists a unique vector such that inner product of x with y, and you also have seen the following. Further, one can make the of all linear functions on X a inner product space by defining y1 prime y2 prime equal to y1, where yi represents so that is the inner product that you have. Okay? And clearly, the induced norm on this inner product space say x star is then norm of y prime equal to norm of, where this is the norm on the inner product space of all linear functionals, and this is the norm on the inner product space induced by the inner product. So this is the summary of what we have obtained. Okay, this could lead to a kind of a confusion here. What is the confusion that can come? Because we are familiar with the dual space. So recall the dual space X taken as a linear space. X prime is the set of all y prime we are confining ourselves to complex vector space, whereas this concept can go far beyond that, because you can talk about any linear space over any field and then talk about the dual space. Okay, but you can't talk about the inner product. You know that this is a linear space, and you know we have the structure, we have already explored it in the general scenario. And what we know is that dimension of x prime equal to dimension of x, which is equal to n. This is one of the results that we have. Suppose x, then we have a basis, a dual basis for the space x prime defined by such that delta ij for I comma j belonging to. So we have already seen, and you know that this is an ordered basis for x prime. Every vector in x prime can be expressed as a linear combination of y1 prime, y2 prime, etc., yn prime. Okay. But we don't have any property like orthogonality or any such thing because we don't have any such structure already available on X. But suppose your X has an inner product. So consider X with an inner product. With the inner product. With the inner product. That is the inner product space X. Okay. Then there exists an orthogonal basis, say and what you have is this xi that's an orthogonal basis. But remember, this is, we can choose this as a basis for x prime also. So you have simultaneously now an x star and an x prime. So what we are trying to find out is how they are related. Okay? Right? So, right, okay. Are they the same? This is something that we looked at. See, there is some problem that we have already observed in this representation theorem. It's not a problem, but some difference that could come, because you see that if y prime is x such that y prime of x with y for every x belonging to x. Then we can write down, we can associate or find out what this vector is. So we will go for the representation. Let us consider this. Okay. So you have y prime is y prime of x is defined as xy, the inner product y. That's how y is fixed. So you have y prime is identified with y. Okay. Let us look at what it is. Right? So what exactly, how y looks like? Y belongs to x. So suppose we write say, okay, what is the dual basis for this is the question that you are asking. One can easily see that the dual basis is x1 prime xn prime x prime such that but if you look at this, so x1, you see that xi prime is identified with xi itself. Okay? Because what do you have? You have xi prime xi in x star. So how these are connected? I mean, that's the question that we are trying to ask. Okay. So how is this x prime and x star are going to be related? So let us start with x prime. After they are as sets, they are the same. As linear spaces, they are the same. Only problem comes because you don't have an inner product there. You don't have an inner product here, but you have an inner product here. That's the difference. Okay. So you take y prime belonging to x prime. Then y prime equal to alpha 1 y1 prime therefore y prime is identified with Cn. That is the identification that you have. Okay? And then you have, what is this alpha by we have alpha I equal to yi or y prime of xi. That is quite easy to find out because this property you make use of. This is the one that you use. Okay. Therefore, y prime is identified with Cn. That's a representation that you have. What about the representation of y prime in the inner product space x star? To the inner product. Okay. Okay, what do you have? See, y prime of x so what is this? This is what we have to see. Okay. Now, suppose, okay, therefore you see that y prime of xi, this is equal to xi y. Okay. So if you write y as alpha 1 x1 plus xn, then